Hello everyone. In this video, we will not cover everything ZNAS can do. That would take much longer. Instead, we want to focus on a specific challenge that every high-performance storage deployment faces: how to achieve and maintain optimal end-to-end performance across the full data path, from the NAS server through the network to the client and accelerator. We will walk you through three concrete capabilities that ZNAS provides to solve this: the Client Toolkit for automated client-side configuration, the built-in health check for deep system analysis, and MCP-based agentic management that makes troubleshooting faster and safer. Let's dive in. ZNAS is delivered already configured for high performance. However, to guarantee strong end-to-end performance and to keep that performance stable over time, it is not enough to configure only the storage server. We also need to configure the clients properly and continuously monitor the whole system for any configuration drift or mismatch with real workloads. To simplify client-side configuration, ZNAS includes a dedicated client-side component called the ZNAS Client Toolkit. This is how it looks. We can run the toolkit directly on each client. It installs all required components, helps connect the client to the ZNAS server, and requires only the essential parameters from the user. All performance-critical settings are selected automatically. In addition, the ZNAS Client Toolkit can detect and fix configuration mistakes made by the user. It also helps manage existing mounts, configure network interfaces, install required packages, and assist with NVIDIA GPUDirect Storage configuration, or analogous technologies for other accelerator platforms, depending on the environment. As you can see in this video, GPUDirect Storage is not configured correctly, and the client software immediately reports this problem. Let's go a little deeper. At first glance, the GPU and RDMA devices are detected, and GDS appears to be active. Let's check the detailed information. Again, everything looks fine at the surface level. But for deeper validation, let's run the verify operation. We select Verify GDS, and the tool immediately shows critical errors that prevent GPUDirect Storage from working correctly. This is important because correct operation of GPUDirect Storage or analogous direct data path technologies on other accelerator platforms is critical for modern AI workloads. Here we can see that the existing cufile configuration is incorrect, and the system warns us about it. However, the user does not need to edit cufile manually. ZNAS Client Toolkit includes an automatic configurator. The configurator understands the available high-performance interfaces, existing mounts, and the target storage topology. Based on this information, it generates the correct cufile configuration automatically. During the process, the tool reports that the current cufile contains errors in specific sections. It backs up the existing file and creates a new, properly configured version. As you can see, the configuration process has completed successfully with no errors. Now we can run verify again and perform an additional test using GDSIO. Let's start a read test with GDSIO. In this example, we run 8 read threads with 1 megabyte read operations. The read test completes successfully. However, the performance is still lower than expected, around 6.5 gigabytes per second. Now we need to understand what is limiting performance. There are several ways to investigate such issues. The first one is the old-fashioned approach. We manually go through the NAS server settings line by line and check every configuration parameter. As you can see, there are many configuration parameters, so this approach can be time-consuming and error-prone. The second approach is to use the built-in health check utility. It performs a deep analysis of the system behavior and generates a report with detected issues. But we recommend using a newer approach. ZNAS includes an integrated MCP server inside the NAS system. This allows you to perform NAS management operations, including troubleshooting and issue remediation, through agentic systems working over MCP. Let's see which capabilities are exposed through the MCP server. We ask our Claude Code agent which tools are available. The agent receives this information from the ZNAS MCP server and shows the list of available tools. As you can see, there are several major domains: user management, pool management, array management, drive management, share management, and network management. There is also one especially important domain for our current case: health check. Through MCP, the agent can run health checks, analyze their results, and work with system configuration. Another important operational principle is that ZNAS supports plan and apply semantics. This means that any configuration change is first planned and reviewed. Only after explicit human confirmation is the change actually applied. Now let's run a health check. We tell the agent that our NAS performance is not optimal and ask it to investigate The agent connects to the ZNAS server, checks the configuration, and runs the internal health check utility. The results are then returned back to the agent through MCP. The agent summarizes the key findings. In this case, the main issue is clear. The number of NFS threads does not match the baseline performance configuration. The agent proposes several remediation options. We select the appropriate fix. The issue is now resolved. In addition, the agent also suggests several less critical improvements that we may apply later. Now we can go directly to the ZNAS server, check the current status, and confirm that the number of NFS threads is now set correctly, in this case to 288. After that, we restart the read test. After these changes, performance has increased by approximately 4 to 5 times. At this point, the result is limited only by the PCI Express configuration of our test environment. This demo shows how ZNAS helps not only deliver high-performance NAS, but also maintain correct end-to-end configuration across servers, clients, networking, and accelerator data paths. With ZNAS Client Toolkit, built-in health check, and MCP-based agentic management, performance troubleshooting becomes faster, safer, and much more transparent.